This is the program for priority queue. So here we have a backup backed file linked heap to perform this priority queue. So initially we are creating a priority queue. So in the constructor, we have initialized this linked heap. So with this heap, we'll be doing performing the actions, adding and removing and all those things. So initially, we are adding these values 11, 7, 8, 6, 5, 9, 4 to this priority queue. So for adding this, we are using this linked heap file, which is there. Here we are using this insert method. So in this insert method, we are first creating a binary node object. That is a node that we need to insert in that heap. So now we are incrementing the size, and if there is no root value, then will be this node which we have to insert will be the root node, root of this heap, and then we'll be returning it. If we already have a node in the heap, then we should then we will already have the self root, so we'll be adding it to the other positions. So here we are taking this root value to the variable node, and then we are having this position which is actually the size of that heap in binary format, and then we are negating the initial that zeroth index, and then while the length of this position is greater than 1, we'll be iterating through that all the nodes of this heap, and then once we reach to that position where we have to add the new node, there will be having the position as here we'll be decrementing the position. So once we reach the last value, then we'll be getting out of this loop, and then if the last or whatever the value is there in the position, either 0 or 1, if it is 0, then we'll be adding that the new node to the left of that node, which is the result of this looping. And if the value is 1 of the position, then we'll be adding the new node to this right of the this node, whatever is the resultant of this looping. And then we are setting the parent, the node which is resultant here, to this node insert this variable that is a new node. To that we'll be assigning the parent node also, which is this node. And then we are doing this float action. So here in this float, we'll be setting the parent value, and then swapping if wherever necessary, if the element which we are adding is less than the parent element, then we'll be swapping it. This is how we'll be inserting the values inside the heap. And after this inserting all these values, then we will be dequeuing that from this priority queue. So that for this dequeuing, we are using this remove method. So this remove method is calling the delete method of this linked heap, and this delete method is internally calling this pop method. So this is the actual method that will be removing the element. So if the size of the heap is 0, then we don't need to perform any action, just we'll be returning it. And if the size is not 0, then we'll have to execute these things. So first thing, we are taking the element which needs to be removed, which needs to be deleted. Okay, so that will be the root element. So now we are taking this root object to this in this variable node, and then if the size is 1, that means we just have that one node inside that heap. So we have to decrement the size, and then we have to return that root that this rs, and then we have to make this root as none. That means we don't have any nodes now. And if the size is more than one, then we have to perform these actions. So first, similar to how we were doing insert, how we were going through the nodes of this heap, similar thing we are doing it here to go through the nodes to set the nodes properly in the arranged manner. We are doing the same activity, and then we are setting. So here we'll be going through the nodes the same way how we used to do it there. And if the position, the result after this looping, if the position value is 0, then we have to remove the left element. And if the resultant value is of this position is 1, then we have to remove the right element, the right side of the resultant node, which is coming out to this variable. Okay, and then for the, once we are removing this whatever the we have to make this left and right to whichever we are node we are removing, so that a link to that node, the parent will be linked to that node, so that link we need to remove, making so that's why we are setting this left and setting this right as none, depending on the position, depending on the what element, what node we are removing, and then we are setting the parent of that particular node which we are removing as none, and then all this we'll be setting this, and then we are decrementing the size, and then we'll be returning that what is that root element. So that will be removed from the linked heap. That is based on the priority, it will be removed. And this is empty is basically if the size is 0, that means this is empty will return at true. And if the size is not equal to 0, that means is empty will return false. And the length will basically it will return the length and the size of this linked heap. So let us execute this program. Okay, so here we are removing is 4, 5, and 6. These will be removed from this list. Okay, and then let's run this linked heap. Actually, linked heap here I'm getting some exception at this point. Even if the node dot get right is none, still the control is getting into this if condition. So that I need to check. So let us run this program as well. So here we are inserting initially we are inserting the value. First we'll be inserting this 11, and then 7 and 11, and then the 7, and then we are inserting this 8, and then we are inserting this 6, 5, and then we are inserting 9, and then we are inserting 4. So these are all arranging itself, and then this is the resultant heap, this one. And then we'll be we are removing this the 4th element, and then the next root element will be 5. Like if you peep, so here if you peek it, that will be 5, and the resultant tree will be the resultant heap will be this thing. Okay, so here we are removing this. This is the actual n that will be removing the 4, and then when we peek, we'll be getting the result as 5. That is the root node, the minimum node, and then the resultant heap. Similar activity we are doing here also. Then the next element that will be removed will be 5, and then the if we peek, it will be getting the 6, and this is the resultant heap. Similarly, the next time 6 will be removed, and then if we peek, we'll be getting the 7, and this will be the resultant heap. And similarly, the next element to be removed is 7, and then the if we peek, we'll be getting this 8, and then this is the resultant heap. So after this, we have to remove this 8, and then the resultant heap will be having as 2 elements, that is 9 and 8, 9 and 11. So those things actually I'm getting some error, so that needs to be checked. And thank you.